You are welcome to the Scholar Online class.
The Scholar School, we establish our footprints on the sand of time. You can't afford to miss any bits of this class. Experience the difference.
Good day. You're welcome to another section of the Scholar Online class, and I'm your tutor for biology, Miss Fatima. And today we'll be doing the continuation of what we started in our last class, where we'll be looking at heredity and evolution, focusing majorly on evolution. We'll be looking at the meaning of evolution, evidence of evolution, going through the homologous organ, analogous organ, and the fossil. Also, we're looking at evolution by stages, where we're looking at fitness advantage, functional advantage, artificial selection, and molecular phylogeny. First, we'll be treating the definition of evolution. And evolution is defined as the natural occurring, slow, and continuous irreversible process of change in a particular living organism. And there are two types of evolution. We have the organic evolution and the inorganic evolution. Organic evolution is the gradual change of living organism from pre-existing organism since the beginning of life. That's organic evolution. For the other one, which is the inorganic evolution, it is the gradual change in elements from one form to another within a particular period of time. Also, we look at evolutionary theory, which states that the different type of plants, animal, and other living organisms on Earth is in correspondence to prehistorical types, and that distinguishable features differences are made due to modification in successive generation. We all know, and we I would like to inform you that the father of evolution is known as Charles Darwin. Is the father of evolution. Moving forward, we'll be talking about microevolution, which is the evolutionary change or evolution that has occurred within a small scale. An example is change in body color of beetles. That's an example of microevolution. Now, the other one where I said evidence of evolution, where we'll be looking at homologous organ, analogous organ, and fossil. For the first one, homologous organs. These are organs that have the same basic structural plan and origin, but they perform different function. An example of homologous organ is the forelimb of horse, which is used for running, the wing of bat, which is used for flying, the paw of cat, which is used for walking and scratching. Now they have the same basic plan, but they perform different function. How? It's the same thing, the same basic but different function. The forelimb of horse is used for running, while that the wing of bat is used for flying, the paw of cat is used for scratching. That's an example of homologous organ. For the other one, which is analogous organ, these are organs that have the same structural function, they are the same but different origin. As I said earlier, that analogous organs, these are organs that have different structure but they perform the same function. And an example is the wing of bat and the wing of bird. They are of different structure but they perform the same function, which is for flight, for flying. Now moving forward, we're looking at fossil. Fossil is a paleontological evidence. What do I mean by paleontological evidence? It means that they are the remains of a particular organism. It might be the bone, it might be the feces, just the remains of a particular organism from pre-existing time, prehistorical time. And the deeper the fossil, the older it is. The deeper the fossil in the ground, that's what I mean, the older it is. Now, moving forward, we'll be looking at the evidence by stages. And the first one is fitness advantage. For fitness advantage, evolution of complex organ is not a sudden occurrence. It takes place bit by bit over generations and due to minor changes such as DNA. However, it takes place bit by bit, like I said earlier, over a particular generation. An example include evolution of eyes in flatworm, which has rudimentary eyes. Insects, they have compound eyes, while man, we have binocular eyes. And another one, like I said, is the functional advantage. For functional advantage, it deals with organs that are used for a particular function, either for adaptation, for protection, for feeding. An example of such function is our feather, the feather that is pregnant in birds, and it helps in providing insulation. Also, it helps for protection also. Now, feathers, bird, they use it for what? Insulation in cold weather. It helps them in keeping their body warm. Looking at the evolution by stage, which is majorly in two aspects, which is the fitness advantage and functional advantage. For the fitness advantage, evolution of complex organ is not a sudden occurrence. It occurs due to minor changes in the DNA. However, it takes place bit by bit over generation. And a typical example is the evolution of the eyes. In flatworm, has become a rudimentary eye, while for insects they have compound eye, while we man we have binocular eye. For the other one, which is functional advantage, when they say something functional, that means the role of a particular part of the body. Now, for the functional advantage, we'll be looking at different organs that perform one or more function. And a typical example is the feather, which is present in birds. Feather provide or serve as insulation during cold weather by helping them in keeping their temperature warm. And it is also used for flight. So this is an organ that has two basic functions. Another one is dinosaurs. They also have feathers, but they could not use it to fly. The feather was just there for protection and also during for as insulation also. So with that, it could have been said that birds later learned to adopt their feathers for flight. So moving forward, we'll be looking at artificial selection, and the use of powerful agents, majorly by our scientists, in modifying wild species to suit their own requirements, their own preference. An example is in wheat. We have many varieties obtained due to artificial selection. And for the last one, we'll be looking at molecular phylogeny. For molecular phylogeny, it is based on the idea that change in DNA during reproduction takes the basic events in evolution. So that means changes during reproduction, either asexual or sexual reproduction, is the basics of evolution. Organisms which are more distinctively related will accumulate greater difference in their DNA. What does this mean? It means the gap between offspring, between relatives, will lead to what? Difference in their DNA, will lead to difference in more generations to come. Thank you for watching. Don't forget to like, subscribe, and share.